Hello, in this lecture we'll find out the radius of the circle. In the drawing we have big semicircle. Inside this big semicircle we have two smaller semicircles and one circle. This gives us the question that this line segment equals to 140 units and this line segment equals to 70 units, this line segment, and our mission is to find out the radius of this small circle. Okay, so first of all we define the relevant points to the question with names. This point will be defined as A. The center of the semicircle will be defined as point B. And here the touching point of the two semicircles will be defined as C. This is the center of the biggest semicircle. We define it as O. This is the center of this smallest semicircle. We define it as D. And we define this point as point E. This is the touching point of the smallest semicircle with the biggest semicircle. We define the center of this circle as F. We define the touching point of the smallest semicircle with the circle as G. And we will define the touching point of this circle with this semicircle as H. And finally, we'll define the touching point of the biggest semicircle with this circle here as point I. And we'll also define the radius of the biggest semicircle as capital R and the radius of this small circle as small r. So I'll write it down. Capital R is the radius of the biggest semicircle. And small r is the radius of the small circle. has given us in the question that the length of this line segment AE is actually 140 units plus 70 units. So we write it down that line segment AE equals to 140 plus 70 units. 140 plus 70 is 210 units. So AE equals to 210 units in its length. But what is actually line segment AE? From the drawing it is very easy to see that AE is the diameter of the biggest semicircle. Okay, AE is the diameter of the biggest semicircle, and we know that the diameter of any circle or semicircle it is twice as long as the radius. And follow the fact that we define the radius of the biggest semicircle as capital R, it means the diameter will be equal to 2 times capital R. So, write it down. AE is the diameter of the biggest semicircle, and therefore it is equal to 2 times capital R. From this long equation, we will conclude, we will derive that 2 times capital R equals to 210 units. 2 times capital R equals to 210 units. Here we'll divide this equation by 2, and we'll get that capital R equals to 210 over 2 is 105 units. So we actually found out that the radius of the biggest circle equals to 105 units in its length. Okay. The radius of this biggest semicircle equals to 105 units in its length. It is given us in the question. So here, write down that OE is the radius of the biggest semicircle. Why? Because of the fact that point O is the center of the biggest semicircle and point E is a point on the biggest semicircle itself. This is exactly the definition of a radius. So OE is the radius of the biggest semicircle that is equal to 105 units. I write it down. Likewise, point O is the center of the biggest semicircle, point A is the point on the biggest semicircle itself, therefore OA it is also the radius of the biggest semicircle that is equal to 105 units in its length. It is given us in the question that line segment AD, this line segment equals to 100, it is line segment AC. This is point A, this is point C, therefore it is line segment AC. This letter is C. So line segment AC equals to 140 units in its length. But what is AC? AC is the diameter of this semicircle, and because of the fact that the diameter of this semicircle equals to 140 units, it means that the radius must be equal to half of it. That is to say, the radius AB equals to 140 over 2, that is 70 units. and the radius BC. Point B is the center of this semicircle. Point C is the point of the semicircle itself. So for BC, it is also the radius of this semicircle that is equal to 70 units. Okay. Likewise, it is given as a question that line segment CE, this line segment, equals to 70 units in its length. What is CE? CE is the diameter of the smallest semicircle, this smallest semicircle. So if CE that is equal to 70 units is the diameter of the smallest semicircle, it means that the radius must be equal to half of it. That is to say, the radius CD of this smallest semicircle equals to 70 over 2. That is 35 units. And the radius CD also equals to 35 units in its length. Okay? In the next step, we'll find out the length of this line segment OB. From the drawing, it is very easy to see that the length of this line segment OB is equals to OA minus BA. We'll repeat again. From the drawing, it is very easy to see that OB equals to OA minus BA. That is to say, OB equals to OA is the radius of the biggest semicircle that is equal to 105 units. Therefore, we substitute OA by 105. Minus BA. BA is the radius of this semicircle that is equal to 70 units. Therefore, we substitute BA by 70. In conclusion, we found out that OB equals to 105 minus 70, that is 35 units. So OB, line segment OB equals to 35 units in its length. So I write down in the drawing itself that line segment OB equals to 35 units in its length. What is the length of this line segment OC? From the drawing, it is very easy to see that OC equals to OE minus OE minus CE. I will repeat again. OC equals to OE minus CE. So OC equals to OE is the radius of the biggest semicircle that is equal to 105 units. So we substitute OE by 105 minus CE. CE is the diameter of the smallest semicircle that is equal to 70 units in its length. So we substitute CE by 70. In conclusion, we found out that OC equals to 105 minus 70, that is 35 units. So OC it is also equals to 35 units in its length. So I write down in the drawing itself that OC this line segment OC equals to 35 units in its length. Okay, so in the next step I will present to you two new rules and we will implement the two new rules in our drawing. According to this rule number 10, if two circles are touching each other internally, here in this drawing, the small circle is inside the big circle and it touches the big circle at point N. Point N is the touching point of the point of tendency of the two circles. And because of the fact that the small circle is located inside the big circle, it is defined as internal touching. They are touching each other internally at point N. Okay, so that is to say, those two circles are touching each other internally at point N. Why? Because this small circle is located inside the big circle. And according to this rule number 10, if two circles are touching each other internally, like in this drawing, then the straight line that connects their centers together. What is the straight line that connects their centers together? Is OM. Why? Because O is the center of the big semicircle, M is the center of the small semicircle, and therefore OM is the straight line that connects their centers together. This straight line OM must pass through their touching point, that is to say, through point N. Or in other words, OMN is one straight line. OMN is one straight line. So I'll repeat again, according to rule number 10, whenever you have two circles that are touching each other internally, then the straight line that connects their centers together, in this case is the straight line OM, must pass through their touching point. Their touching point is at point N, and therefore OMN is one straight line. Okay, and what is the distance OM between the centers of the two circles? From the drawing it is very easy to see. We know that capital R is the radius of the big circle and small r, MN is small r, it is the radius of the small circle. And the distance OM between the centers of the two circles, from the drawing it is very easy to see that OM equals to NO, and NO is capital R, minus MN. MN is small r. That is to say, we found out that the distance OM between the centers of the two circles equals to capital R minus small r. And capital R minus small r is the difference between the centers of the two circles. That is to say, you can conclude that whenever two circles are touching each other internally, the distance between their centers will be equal to the difference between their radii. In this case, it is capital R minus small r. So D, the distance that is equal to MO equals to capital R minus small r. Okay. And we have also rule number 11. According to rule number 11, if two circles are touching each other externally, in this domain we have the two circles are touching each other externally at point N. Why it is defined, this point of tangency of this touching point that is at point N is defined as externally because of the fact that none of those two circles are located inside the other, and therefore they are touching each other externally at point N. So whenever you have an external notch between two circles, like in this drawing, those two circles are touching each other externally at point N, then the straight line that connects your centers together, point O is the center of the big circle, point M is the center of the small circle, and therefore OM is the straight line that connects their centers together. According to this rule, rule number 11, the straight line OM must pass through their touching point, that is actually point N. Or in other words, O and M is one straight line. O and M is one straight line. And what is the distance between their centers? The distance between their centers is OM. But what is the length of OM? From the drawing, it is very easy to see that OM equals to ON plus MN. Why? Because of the fact that O and M is one straight line, it means that OM equals to ON plus NM. ON is capital R and M is small r. Therefore, OM, that is the distance between the centers of the two circles, equals to capital R plus small r. Okay, D, that is equal to OM equals to capital R plus small r. So I can conclude from it that whenever you have an external notch between two circles, like in this drawing, the two circles are touching each other externally at point N, then the distance OM between their centers will be equal to the addition of the two radii with each other. That is to say, it is capital R plus small r. The distance D that is equal to OM equals to capital R plus small r. So we can actually implement the two new rules in our drawing. Why? Because in our drawing we have point B, that is the center of this semicircle, and we have point F, that is the center of this circle. And the straight line that connects their centers together, it is of course BF. This is a straight line BF. According to rule number 11, this semicircle and this circle have an external notch between them at point H. That is to say, they are touching each other externally at point H. Therefore, according to rule number 11, the straight line that connects their centers together, that is actually BF, must pass through their touching point, that is point H. That is to say, BHF is one straight line. BHF is one straight line. And because of the fact that the BHF is one straight line, it means that the distance FB or BF, although it is very easy to see that that is actually FH plus HB. But FH is the radius of this circle that is small r, and BH, it is the radius of this semicircle that is equal to 70 units according to what we have already found out. And it is exactly according to rule number 11 that the distance BF between their centers equals to the addition of the two radii with each other. The radius of this circle is smaller, the radius of this semicircle is 70, and the addition of the two radii is 70 plus r. So you can write down that BF equals to 70 plus r units according to rule number 11. FB equals to 70 plus small r units likewise, we will join the center of the smallest semicircle that is located here at point D with the center of this circle that is located here at point F. So we join the two centers together by a straight line. And according to the same rule, rule number 11, the straight line that connects with your centers together, that is actually FD, must pass through their touching point that is located here at point G. That is to say, FGD is one straight line. FGD is one straight line. And the distance FG between the radii will be equal to the addition of the two radii with each other. FG is the radius of the small circle that is equal to small r. GD is the radius of the smallest semicircle that is equal to 35 units. The addition of the two radii with each other will give us 35 plus small r. So the distance FD between their centers equals to 35 plus r units. FD equals to 35 plus r units. In the next step, we join the center of this semicircle that is located here at point B with the center of the smallest semicircle that is located here at point D. In other words, we join points B and D together by a straight line. So here we use again rule number 11. Why? Because those two small semicircles have an external notch between them at this point, point C. That is to say, they are touching each other externally at point C. Okay, and whenever you have an external notch between two circles or semicircles, the straight line BD that connects their centers together must pass for their touching point, that is actually point C. That is to say, BCD is one straight line. And because of the fact that BCD is one straight line, it means that the distance BD between their centers will be equal to the addition of the two radii with each other. So BD equals to the radius of this semicircle that is equal to 75 plus, that is equal to 35 plus 35, that is 70. Plus the radius of the smallest semicircle that is equal to 35 units. So in conclusion, we found out that the distance BD between the centers of the two semicircles equals to 70 plus 35. 70 plus 35 is 105 units. Okay. So BD is the addition of the two on the eye with each other, and it is equal to 105 units. In the next step, we will join together the center of the biggest semicircle that is located here at point O with the center of this small circle that is located here at point F. So we will join points O and F together by a straight line. Okay, we joined the center of the biggest semicircle with the center of this circle. So the biggest semicircle have an internal notch between with this circle. Why? Because of the fact the small semicircle is located inside the biggest semicircle. Therefore, they have an internal notch between them at point I. That is to say, they are notching each other internally at point I. And whenever you have an internal notch between two circles or semicircles, then the straight line that connects their centers together is OF, must pass for their touching point, that is to say for point I. That is to say OFI is one straight line. OFI is one straight line. So what is the length of FO? FO or OF is the distance between their centers. Actually, whenever you have an internal notch between two circles or semicircles, the distance between their centers FO will be equal to capital R minus small r, that is the difference between their radii. Capital R is the radius of the biggest semicircle, small r is the radius of this small circle, and the difference between the radii is capital R minus small r. Okay, so FO equals to capital R. We have already found out that capital R, that is the radius of this biggest semicircle, equals to 105 units in its length. So we substitute capital R by 105 minus small r. Small r is the radius that we are looking for, so we'll leave it as it is. So in conclusion, we found out that FO, this line segment FO, that is the distance between the center of the biggest semicircle and the center of this circle that is located here, FO equals to 105 minus small r units. So I write it down. The length of line segment FO, it is actually 105 minus small r units. So In the next step, I will present to you a new rule, and we will implement the new rule. we'll implement the new rule in this triangle BFD. I repeat again, we will implement the new rule in this green triangle BFD. The new rule is true in any triangle. The new rule is called Stewart's Theorem. Because of the fact that the new rule is true in any triangle, therefore the triangle that I will draw, triangle ABC, could be any triangle. This is triangle ABC. This could be any triangle. We know that the length of side AB is A, side AC equals to B units in its length, and finally this side BC equals to C units in its length. And we have here line segment AC, line segment AD. This is line segment AD, and the length of this line segment AD, is equal to D units in its length. In addition, we know that the length of this line segment BD, equals to M units in its length, and finally line segment DC equals to N units in its length. Okay. According to Stewart's theorem, the following equation is true. A squared times N, A squared times N, plus B squared times M, equals to, the other side of the equation we have C is the length of side BC. We'll open the brackets, and inside the brackets we have D squared plus M times N. I repeat again. According to Stewart's theorem, that is true in any triangle, A squared times N plus B squared times M equals to C, and inside the brackets we have D squared plus M times N. Okay, so we can actually implement the new rule in our green triangle FBD. So I'll copy triangle FBD in a new page and we'll implement Stewart's theorem on the green triangle, triangle FBD. We have already found out that the sides of all the sides of the green triangle, triangle FBD, so I will not repeat on it. This is triangle FBD that I copied from the original drawing, the green triangle, triangle FBD. We have already found out that the length of side FB is 70 plus small r units. We have already found out that FD equals to 35 plus r units. We have already found out that the length of side BD equals to 105 units in its length. Here we have also line segment FO. We have already found out that the length of this line segment FO, it is equal to 105 minus r units. What is the length of this line segment BO? From the drawing, it is very easy to see that the length of line segment BO is 35 units. So I write it down. BO equals to 35 units. And finally, what is the length of line segment OD? From the drawing, it is very easy to see that OD, this line segment OD, equals to 35 plus 35 units. OD equals to OC, that is 35, plus CD, that is also 35. So 35 plus 35 is 70. OD equals to 70 units in its length. So in the next step, we will implement on this triangle Stewart's theorem. So according to Stewart's theorem, we get that in this triangle FBD, FB squared times OD, FB squared times OD, plus FD squared times BO, equals to BD. We'll open here brackets, and inside the brackets we'll have FO square plus BO times OD. BO times OD. So this equation is the implementation of Stewart's theorem in our triangle FBD. FD squared times OD plus FD squared times BO equals to BD. We open the brackets. Inside the brackets we have FO squared plus BO times OD. So FB is 70 plus R, therefore FB squared is 70 plus R squared times OD. OD equals to 70, so we substitute OD by 70 plus FD squared. FD is 35 plus R, therefore FD squared is 35 plus R squared times BO. BO is 35, so we substitute BO by 35. And it is equal to BD. BD is 105, so we substitute BD by 105. We open the brackets. Inside the brackets we have FO squared. FO equals to 105 minus R, therefore FO squared equals to 105 minus R squared. Plus BO times OD. BO is 35 and OD is 70. Okay. In the next step we will define the number 35 as x, and we'll substitute 35 for any multiplication of 35 by a natural number. We'll substitute it by x. So in the equation we have 70. 70 is 35 times 2 times 35, and 35 is x. So 70 is 2x. We substitute 70 by 2x plus R squared times 70. 70 is 2x, so we substitute 70 by 2x plus 35 plus R squared is 35 is x, so it is x plus R squared times 35. 35 is x, so we substitute 35 by x. And it is equal to 105 is 3 times 35. And 35 is x, therefore 105 is 3x. We substitute 105 by 3x. Inside the brackets we have again 105, this is actually 3x. Minus R squared plus 35 is x, so substitute 35 by x, and 70 is 2 times 35, that is 2x, so substitute 70 by 2x. Okay. So we will open brackets here, 2x, but before that we will divide this equation by x. So here x will get cancelled, here also x will get cancelled, and here x will get cancelled. So what is left from this equation after we cancelled x? We have 2x plus r squared times 2 plus x plus r squared equals to 3, and inside the brackets we have 3x minus r squared plus x times x is 2x squared. Okay, we have this equation. After we divide the original expression by x, we got this expression. We will open the brackets here. We have 2 times 2x plus r squared. 2x plus r squared equals to 2x squared, that is 4x squared, plus r squared, plus 2 times 2xr is 4xr, plus x plus r squared, so we'll open the brackets, x plus r squared equals to x squared plus r squared plus 2xr. And it is equal, on the other side of the equation we have 3, inside the brackets we have 3x minus r squared, according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab. We get that 3x minus r squared equals to 3x squared. 3x squared is 9x squared plus r squared minus 2 times 3x r is minus 6xr. Plus 2x squared. Here we'll open the brackets and we'll get that 2 times 4x squared is 8x squared plus 2 times r squared is 2r squared plus 2 times 4xr is 8xr plus x squared plus r squared plus 2xr. And in the other side of the equation we have, it is equal to inside we have 3, and inside the brackets we have 9x squared plus 2x squared is 11x squared minus 6xr plus r squared. So we have here 8x squared plus x squared is 9x squared two r squared plus r squared is 3x squared and we have here 8xr plus 2xr is 10xr. Okay, so in this side of the equation we have 9x squared, in total 9x squared plus 3r squared plus 10xr equals to, in the other side of the equation we will open the brackets 3 times 11x squared is 33x squared three times minus 6xr is minus 18xr and 3 times r squared is 3r squared. So we have here 3r squared on both sides of the equation, so 3r squared will get cancelled. And what is left after we cancel 3r squared? On those sides of the equation, on this side of the equation we have 9x squared plus 10xr equals to 33x squared minus 18xr. Here we subtract 9x squared from this equation and we get that 9x squared minus 9x squared is 0, so on this side of the equation we left only if 10xr, and here on the other side of the equation we have 33x squared minus 9x squared is 24x squared minus 18xr. Here we will add 18xr to this equation and we get that 10xr plus 18xr is 28xr and it is equal to 24x squared. 18xr minus 18xr is 0. So in conclusion we found out that 28xr equals to 24x squared. Here we will divide this equation by x and we get that 28xr over x is 28r and it is equal to 24x squared over x is 24x. So in conclusion we found out that (28r) equals to 24x. Repeat again, we found out that 28r equals to 24x. Here we will substitute x by 35 because x equals to 35 according to our definition, and we get that 28r equals to 24x and x is 35, so we substitute x by 35. So we found out that 28r equals to 24 times 35. Here we will divide this equation by 7 and we get that 28 over 7 is 4. So in this side of the equation we have in total 4r that is equal to 24 and 35 over 7 is 5. So in total in this side of the equation we have 24 times 5 So 4r equals to 24 times 5. Here we divide this equation by 4, and we get that 4r over 4 is r, and it is equal to 24 over 4 is 6. So in total, on this side of the equation, we have 6 times 5. We found out that r equals to 6 times 5, that is 30. R equals to 30 units. Okay, so the length of the radius of the circle, that is the radius that we are looking for, small r, it is equals to 30 units. So we write it down here. R equals to 30 units in its length. And that is the answer to the question. In the next step, I will summarize the lecture. In the drawing, we have a big semicircle. Inside this big semicircle, we have two smaller semicircles and one circle. It is given as the question that line segment AC equals to 140 units and line segment CE equals to 70 units, and our mission is to find out the radius of this small circle. Okay. So first of all, we give names to the relevant points to the questions here, and we define the radius of the biggest semicircle as capital R. We also define the radius of this small circle as small r. That is the radius that we are looking for. Repeat again. Capital R is the radius of the biggest semicircle. According to our definition, and small r is the radius of the circle. That is the radius that we are looking for. It is given as the question that line segment AE equals to 140 plus 70 units. AE equals to 140 plus 70, that is 210. So AE equals to 210 units. But what is actually line segment AE? Line segment AE is the diameter of the biggest semicircle. And we know that the diameter of any circle or semicircle is twice as long as the radius. And because of the fact that the radius of the biggest semicircle is defined as capital R, it means that the diameter must be equal to 2 times capital R. Here, the diameter of the biggest semicircle equals to 2 times capital R. And from this long equation, 2 times capital R equals to the diameter equals to A equals to 210, we will derive that 2 times capital R equals to 210. 2 times capital R equals to 210. We divided this equation by 2 and found out that capital R, that is the radius of this biggest semicircle, equals to 210 over 2 is 105 units. So here AO, that is the radius of the biggest semicircle, equals to 105 units, and also OE, the radius of the biggest semicircle, equals to 105 units. Okay, then it is given us the question that AC equals to 140 units in its length. But what is AC? AC is the diameter of this semicircle, and if the diameter equals to 140, it means that the radius AB equals to 140 over 2, that is 17. The radius BC of this semicircle equals also to 70 units. Likewise, we have this gives us the question that CE equals to 70 units. CE is the diameter of the smallest semicircle and is equal to 70 units. Therefore, the radius CD must be equal to 70 over 2, that is 35 units, and the radius DE also equals to 35 units. Then we found out the length of this line segment OB. It is very easy to see that OB equals to OA minus BA. I'll repeat again. OB equals to OA minus BA. OA is the radius of the biggest semicircle that is under 5 units, and BA is the radius of this semicircle that is 70 units. So, in conclusion, we found out that OB is 105 minus 70. 105 minus 70 is 35 units. So OB equals to 35 units in its length. Likewise, we found out the length of this line segment OC. From the drawing, it is very easy to see that OC equals to OE minus CE. Again, OC equals to OE minus CE. Repeat again. OC equals to OE minus CE. So here, OE is under 5 units, it is the radius of the biggest semicircle, and CE is 70 units. Therefore, OC equals to 105 minus 70. 105 minus 70 is 35. So I found out in conclusion that OC equals to 35 units in its length. In this line segment, OC equals to 35 units. In the next step, I presented to you 2 new rules, and we implemented the 2 new rules in our drawing. Actually, we have here rule number 10. According to rule number 10, if 2 circles are touching each other internally, we have the small circle is located inside the big circle, and it touches the big circle at point N. Point N is the point of tendency of the touching point between the 2 circles. Then the straight line that connects their centers together, the center of the big circle is at point O, the center of the small circle is at point N, and the straight line that connects their centers together is the straight line OM. This straight line OM must pass through their touching point, that is here at point N. Or in other words, OMN is one straight line. Again, OMN is one straight line. And what is the distance between their centers? It is also OM, and OM equals to NO minus NM. NO is capital R, NM is small r, and therefore OM equals to capital R minus small r. So whenever you have an internal length between 2 circles, that is to say that they are touching each other internally, then the difference between the distance between their centers, MO, will be equal to the difference between their radii. In this case, it is capital R minus small r. And we also have rule number 11. According to rule number 11, if 2 circles are touching each other externally, here none of the 2 circles are located inside the other, and therefore they are touching each other externally at point N. Then the straight line that connects their centers together is OM. Why? Because point O is the center of the big circle, and point M is the center of the small circle. So OM is the straight line that connects their centers together, must pass for the attaching point, that is actually point M. Or O and M is one straight line. Again, O and M is one straight line. And therefore, the distance OM, because of the fact that O and M is one straight line, so the length of OM will be equal to ON plus NM. ON is capital R and M is small r. So whenever you have an external notch between two circles, like in this drawing, that is to say the two circles are touching each other externally, then the distance between the centers of the circles will be equal to the addition of the two radii with each other. In this case, it is capital R plus small r. So OM equals to capital R plus small r. We implemented the two new rules in our drawing. Point F is the center of this small circle. Point B is the center of this semicircle. The circle and the semicircle have an external notch between them at point H. That is to say, they are touching each other externally at point H, and therefore the straight line that connects their centers together, that is to say FB, must pass through their touching point, that is actually point H, or FHB is one straight line. FHB is one straight line, and according to rule number 11, the straight line FB that connects their centers together equals to the addition of the two radii with each other. That is to say, the radius of this small circle, that is small r, plus the radius of this semicircle, that is 70. Or in other words, FB equals to r plus 70 units. Okay? Here, FB or BF doesn't matter. FB equals to 70 plus r units. Likewise, we join the center of the semicircle that is located here at point F with the center of the smallest semicircle that is located here at point D. The smallest semicircle have an external notch between this circle at point G. That is to say, they are touching each other externally at point G. And therefore, the straight line that connects their centers together, FD, must pass through their touching point. That is to say, for point G. Or FGD is one straight line. FGD is one straight line, and therefore, the distance FD between the centers of the two circle and semicircle is equal to the addition of the two radii with each other. The radius of this circle is small r. The radius of the smallest semicircle is 35. And the distance FD between their centers will be 35 plus r. Okay, so FD equals to 35 plus r units. Then we join the center of this semicircle that is located here at point B with the center of the smallest semicircle that is located here at point D. Okay, so the straight line BD that connects their centers together must pass through their touching point that is located here at point C. Or BCD is one straight line. BCD is one straight line, and because of the fact that the two semicircles have an external notch between them at point C, therefore the distance between their centers BD will be equal to the addition of the two radii with each other. The radius of this semicircle is 70 units. The radius of this, the smallest semicircle, is 35. So the distance between their centers BD equals to 70 plus 35, that is 105 units. Here we found out that BD equals to 105 units. 70 plus 35, this is 105 units. Then we join the center of this small circle that is located here at point F with the center of the biggest semicircle that is located here at point O. Okay? So because of the fact that this small semicircle is located inside the biggest semicircle, therefore the small circle have an internal notch with the biggest semicircle here at point I. That is to say they are touching each other internally at point I. And therefore the straight line that connects their centers together, that is actually OF, the straight line OF must pass through their touching point, that is to say for point I. Or OFI is one straight line. OFI is one straight line. And therefore the distance between their centers OF will be equal to the difference between their radii. The radius of the biggest semicircle is equal to capital R. The radius of the small circle is small r. And the difference is capital R minus small r. So OF or FO equals to capital R minus small r. You can see it actually from the drawing. Also, that IO, that is the radius of the biggest semicircle, and it is equal to capital R minus Fi, that is equal to small r, it is the radius of the small circle, will give us exactly Fo. Again, capital R, that is the radius of the biggest semicircle, minus the radius of this small circle that is equal to small r. Capital R minus small r equals to Fo, that is the distance between their centers. I'll repeat again. Fo equals to capital R minus small r. We have already found out that capital R, the radius of the biggest semicircle, equals to 105 units. Therefore, we substitute capital R by 105 and we got that Fo equals to 105 minus r. If Fo, the length of this line segment Fo equals to 105 minus r. In the next step, I presented to you a new rule, and we implemented a new rule in the green triangle, triangle FBD. The new rule is Stewart's theorem. According to Stewart's theorem, Stewart's theorem is true in any triangle, so here triangle ABC could be any triangle. The length of side AB is A units. Side AC equals to B units in its length. And finally, side BC equals to C units in its length. Line segment AD equals to D units in its length. Line segment BD equals to M units. And line segment DC equals to N units in its length. Then the following equation is true, that A squared times N plus B squared times M equals to C. You open brackets. Inside the brackets we have D squared plus M times N. Plus M times N. Again, A squared times N plus B squared times M equals to C. We open brackets, and inside the brackets we have D squared plus M times N. Implemented the new rule in our green triangle, triangle BFD. So this is the green triangle, triangle BFD or FBD that I copied from the original drawing. We have already found out the lengths of all the sides of the triangle, and we also found out that Fo equals to 105 minus r units. And we implemented Stewart's theorem in this triangle, triangle FBD. According to Stewart's theorem, we get that FB squared times OD plus FD squared times BO equals to BD. We open brackets. Inside the brackets we have FO squared plus BO times OD. Again, FB squared times OD plus FD squared times BO equals to BD. We open the brackets. Inside the brackets we have FO squared plus BO times OD. If FB equals to 70 plus r, and therefore p square is 70 plus r square times OD is 70, so we substitute OD by 70, plus FD square. FD is 35 plus R, therefore FD square is 35 plus R square, times BO. BO is 35, so we substitute BO by 35. And it is equal to, in the other side of the equation, we have BD. BD is 105, so we substitute BD by 105. We open brackets. Inside the brackets, we have FO square. FO is 105 minus R, therefore FO square is 105 minus R square, plus BO times OD. BO is 35 and OD is 70. Okay, then we defined 35 equals to x according to our definition, and we substituted 35 for any multiplication of 35 by a natural number. We substitute it by x in this equation, and we got that 70 is 2 times 35, that is to say it is 2x plus r square times 70 is 2x plus 35 is x, so it is 35 plus r is x plus r square times 35 is x, so we substitute 35 by x, and it is equal to 105 is 35, 3 times 35, that is to say it is 3x. Inside the brackets we have also 105, that is also 3x. 105 minus r square is 3x minus r square, plus x, 35 is x, times 70 is 2x, so it is 35 times 70 is x times 2x. Then we divided this equation by x, so here x will get cancelled. So what is left from the equation after we cancel the x? We have here 2x plus r square times 2 plus x plus r square equals to 3. We open the brackets. Inside the brackets we have 3x minus r square plus 2x square. We open the brackets here. We have here 2 times 2x plus r square is 2x squared, that is 4x square, plus r square, plus 2 times 2xr is 4xr. We open the brackets here. X plus r square equals to x square plus r square plus 2xr. In the other side of the equation we have it is equal to 3. Inside the brackets we have 3x minus r square is 3x squared, that is 9x squared, plus r square minus 2 times 3xr, that is minus 6xr, plus 2x squared. Here we open the brackets. We have 2 times 4x squared is 8x squared, 2 times 4xr is 8xr, and 2 times r square is 2r square, plus x square plus r square plus 2xr equals to 9x square plus 2x square is 11x square minus 6xr plus r square. Here we have 8x square plus x square is 9x square, 2r square plus r square is 3r square, and we have 2xr plus 8xr is 10xr. In the other side of the equation we open the brackets. 3 times 11x square is 43x square, and 3 times minus 6xr is minus 18xr, and 3 times r square is 3r square. We have 3r square on both sides of the equation, so 3r square we get cancelled, and we left only in this side of the equation with 9x square plus 10xr. In the other side of the equation we have it is equal to 33x square minus 18xr. Here we subtracted from this equation 9x square, so 9x square minus 9x square is 0, so in this side of the equation we left only with 10xr, and it is equal to 33x squared minus 9x squared is 24x squared. We have also here minus 18x squared. So if we found out that 10xr equals to 24x squared minus 18xr. We added 18xr to this equation and we found out that 10xr plus 18xr is 28xr. This is equal to 24x squared. 18xr minus 18xr is 0. So we found out that 28xr equals to 24x squared. We divided this equation by x. 28xr over x is 28r. And this is equal to 20x squared over x is 24x. So in conclusion, we found out that 28r equals to 24x. Yeah, 28r equals to 24x. We substitute x by 35 and we found out that 28r equals to 24, x is 35. So 28r equals to 24 times 35. We divided this equation by 7 and found out that 28 over 7 is 4. In this side of the equation we have in total 4r and it is equal to 24 times 35 over 7 is 5. So in total in this side of the equation we have 24 times 5. So we found out that 4r equals to 24 times 5. We divided this equation by 4 and we found out that 4r over 4 is r and 24 over 4 is 6. So in total in this side of the equation we have 6 times 5. So r equals to 6 times 5. 6 times 5 is 30. So we found out that r, the radius of this circle, the radius that we are looking for, it is equal to 30 units in its length. Okay, thank you very much.